Okay, so we are going to start looking at lesson number 7, which is combining the laws of logarithms. But before we do, a word from our sponsor.
Hey guys, it's Nick, and after looking over this lesson, I'm here to tell you it does not get any harder. A whole lot more complicated though, so good luck.
See you later. All right, so thank you to Nick Yasinchuk for that. What we were doing yesterday was we were looking at the different log laws. And so the first one we looked at was the product law, and then we looked at the quotient law, and then we looked at the power law. If you want to review these laws, then we have log A times our arguments, m times n, is the same thing as saying log A argument m plus log A argument n. The quotient law is similar, but instead of multiplying and adding, we're dividing our arguments and subtracting our arguments. And then with the power law, we have our arguments, and we can rearrange it so the exponent on our argument becomes a coefficient, and the argument stays the same. So today what we're going to do is we're going to begin to combine these different laws. Okay, so let's look at the first example here. So we're calling class example number 5 from lesson number 6 that we came up with this question here. So we want to determine the value of 3 log 2p minus 3 log 2q, and if we rearrange this, we would get p of q, which is equal to 8. Now show how this problem can be solved using a combination of the laws of logarithms without removing our common factor. Okay, so if I have log, or 3 log 2p minus 3 log 2q, the first thing I want to do is I want to get that term p divided by q is equal to 8. Even before I get that term, though, I can rearrange this. So if you notice that if I have 3 log 2p minus 3 log 2q, I can actually convert this so I have something similar, or I can use the power law in order to get my exponents and to get my coefficients as my exponent on my argument. And so the first thing I'm going to do is rearrange this term here using the power law. Okay, so this becomes log 2 of p to the power of 3 minus log 2q to the power of 3. All right, now I can use another law. Look at the subtraction sign in the middle here. That tells me that I can use the quotient law. So if I rearrange this using just the same base, log 2, I'm not converting any of the bases, but I'm taking my arguments and I'm going to divide them. That becomes p to the power of 3 divided by q to the power of 3. And I can also state this as log 2, and if I use my exponent laws, I can say that both the p and the q are raised to the power of 3. So if I express that as one term raised to the power of 3, that is the exact same thing. Now what I have here is log 2p divided by q to the power of 3. And remember that if I again use the power law, I can create a coefficient with this exponent. This would then become 3 log 2 p divided by q. And remember that p divided by q is equal to 8. And so what I've done is I've simplified this by using so far two different logarithm laws. So if I were to work down here now, I can say this as 3 log 2 8, because remember p divided by q is equal to 8. And I can go even further by continuing to use the power law, and that's going to become 3 log 2. Remember, 8 can be expressed as 2 to the power of 3. 2 to the power of 3. And this 3 I can also take down, and this will become 3 times 3 log 2, 2. if I have log 2 of 2, or log 10 of 10, or log 3 of 3, that's always going to equal 1. So I'm going to be left with 3 times 3 log 2 of 2 is equal to 1, which is equal to 9. All right, so it seems like a long process, but once you get the hang of using these power laws, or these log laws, then it's not as difficult as it looks here. It will probably take long though. So let's look at example 2. Use the laws of logarithm to write 1/2 log a16 minus 1/3 log a of 8 as a single logarithm. All right, so one thing we can do is we can get rid of these coefficients and make them exponents. And to do that, we could use the power law. So this would become log a 16 to the 1/2 minus log a 8 to the 1/3. Now 16 to the power of 1/2, we can express that, remember, as square root 16, which is the same thing as saying log 4. And if I were to take the cube root of 8, or 8 to the power of 1/3, that's the same thing as 2. Cube root of 8 is 2. And all I'm doing is I'm simplifying it and making it numbers that are more manageable to work with. Now I can use my quotient law because I have my subtraction sign here. So this is going to become log a 4 divided by 2, or simply log a 2. And this would be my final answer. Now, if a is equal to 32, what we want to do is evaluate this expression. So if I have log 32 of 2, remember we can rewrite this as log 2 divided by log 32. And now it's just a matter of inputting into our calculator. Log 2 divided by log 32. And the answer we get is 0.2, or same thing, 1/5. All right, we're still doing the same thing. Now we want to evaluate without using our calculators. All right, so we're still using our log laws. The first one we want to use is our quotient law here. And so I'm going to be left with 3 log x minus, remember I can make, if I have an exponent, I can bring that down as a coefficient and it'll become 3 log x. Well, if I have 3 log x minus 3 log x, I don't actually have to evaluate anything because I know that if I have a whole number minus the opposite, or adding the opposite, I'm going to get 0. Next one, it might be easier if I have, I can easily, again using my power law, use these as exponents. So I can rearrange this to be log 5 squared plus log 2 squared. I could express this as log 25 plus log of 4. Now, I can still use my logarithm laws, right? This is going to be the product law because I have an addition sign here. So this is going to become log 25 times 4, or log 100. And this is something that is pretty easy to now calculate, right? Because I can express log 100 as log 10 of 10 squared. Log 10 of 10 squared, this 2 can become a coefficient, which would be 2, if I'm using my power law, log 10 of 10. And remember, if I have log 10 of 10 or log 2 of 2, that's always going to equal 1. So I'm going to be left with 2 times 1, which is equal to 2. Now, if log 2 of x is equal to a, determine an expression for log 2 of 16x squared. All right. Log 2 of 16x squared. We can express this as log 2 of 16 plus log 2 of x squared. The reason we can do this is because I multiplied. So what I'm doing is I'm using my product law, and I'm going the opposite way. So if I'm multiplying these two terms, then if I'm multiplying two arguments, I can also add those two arguments in their separate logs. All right. Next, I could convert this into an exponential form. So a type of exponential form, right? So 16 as base 2 would be 2 to the power of 4. And I'm going to also add my, if I were to get rid of this exponent, I could express that as log 2 of x. Now, since I'm expressing this as a coefficient, I can also express this as a coefficient, which would leave me with 4 log 2 of 2 plus 2 log 2 of x. Now, remember that if I have log 2 of 2, that's the same thing as just 1. And I know that log 2 of x is equal to a, because that's what the question initially told me. So I'm going to be left with 4 times 1 plus 2 log 2 of x was equal to a, so 2a. And I'm going to be left with 4 plus 2a as a final answer. And we'll skip this question down here, and you guys, we'll just have a shorter video for today.